Hi everybody, let's talk about lockout tagout for a few minutes. Lockout tagout, there's two different trainings that we typically do. Lockout tagout for the affected employee, sometimes we'll call it the other. Affected employees, people that work around the equipment or may work in the area, which could be some of the other people. Then we have lockout tagout authorized, which is the ones who are authorized to apply the locks and tags and go into the point of operation, bypassing guards by utilizing lockout tagout to service or repair equipment or something along that line. So let's talk about that for just a moment. See here, there are types of employees. We just talked about them. The employees or the employer authorizes certain employees to bypass guards and enter into the machine's point of operation. They're called the authorized employees. They're the ones who's responsible for locking and tagging out the machine before performing some kind of work or some kind of maintenance, repair, whatever it might be. And then there's the affected employees, an employee who is responsible for operating the equipment, or maybe they just work somewhere in the area and they need to know when they see locks and tags, they need to know what those are for or what they represent. Now, keep this in mind because make sure you don't run into this. Affected employees cannot help authorized employees. Why? Because they're not authorized. They don't go through the training. They go through, affected employees go through awareness type training. Authorized employees go into detail type training. So we have to keep that in mind when they're working on a piece of equipment. But it's critically important that the affected employee understand the lockout tagout program and they understand the procedures, so when they see it happening they know what's going on and know not to try to start up a piece of equipment. Now if the authorized person has done their job properly and followed the procedures, the affected person couldn't start it up if they wanted to. Anyway, when we talk about lockout definitions, we talk about the process of preventing the flow of energy into a piece of machine, and there's a number of ways of doing that. Locks, blocks, chains, disconnects, whatever it might be. But it requires an authorized person to apply that lock right here. And I say this a lot, if you can see this pretty good. How many people are working on this particular piece of equipment? You see there are 3 locks. 147 requires that everyone that's working on that piece of equipment apply their lock. So that tells me there are 3 people working on this particular piece of equipment. Now I should be able to walk over here and look at the locks, and it should identify the person who is working on it or applied it. So each lock should have the person's name or maybe a picture or something along that line on the lock identifying who put it on there. Now when we talk about tag out, so there's no doubt there's some pieces of equipment you just can't put a lock on. So a tag, it replaces that. It acts as a warning. It must clearly state do not operate. A tag must be used when the machine won't accept the lock, and a tag must be applied and removed by that authorized person. Typically your maintenance folks are your authorized people who apply locks and tags onto a piece of equipment. Now, there's a lot of different hazards out there and different energies that a lot of people work with. One is electrical, mechanical, pneumatic, hydraulic. You may have all 4 of those. And then there are chemical, thermal, water under pressure, gravity, and potential energy. There's only 2, potential or kinetic, something along that line. And then we have to have an energy control program in place. Energy control procedures. You'll see on some of the sides of the machines there will be posters, has lockout tagout procedures written on it. Also, we have a lockout tagout written program that tells what those procedures are, how we're going to follow them, how we're going to conduct it, and how we're going to update them. So that's what the energy control procedures is all about. Then we do periodic inspections. OSHA has defined periodic as at least annually, at least once a year. We have to go through and make sure the procedures that are posted on the side of those machines, make sure they're still accurate, they still provide safety for the employee who's working on it, and it is a surefire way of locking out and killing all the energy that's coming into that equipment so maintenance or employees can work on it safely. Now also we have employee training. That's exactly what we're doing right now. We're talking about all the different aspects of lockout tagout as affected employees would deal with it. Now when I put together a lockout tagout program, I kind of like to use 6 steps, 6 simple steps. First off, we're going to prepare for the shutdown. We know this piece of equipment over here needs a part replacement on it. I have the part here. I have everything ready. So now we're going to shut down the equipment using normal shutdown procedures. We're going to isolate the equipment from the energy. Now, if this equipment has electrical and then hydraulic, I'm going to go over and turn the disconnect off, lock it out, go turn the hydraulics off, lock it out, so no one can come along behind me and turn it back on while I'm in there working on that piece of equipment. So I applied my locks and tags. I release any stored energy, and that's something I want to check carefully. Sometimes hydraulic lines, if they don't depressurize when you turn them off, I think today most of them do, but if they don't, then you have to make sure you understand you need to bleed off that pressure. Same way with air lines and sometimes even water lines. Make sure you bleed off that pressure. Now, once you've done all of that, you want to verify isolation. Now, how do you do that? It's pretty simple. You just basically walk over and hit the start button. And if the machine tries to start up, you've missed a source of energy. If the machine lays dormant and it doesn't move, then you've successfully locked out the piece of equipment. Now, keep in mind, only authorized employees can remove and attach locks and tags and things of that nature. The devices have to be durable. It can't be a piece of tape or a piece of paper or something along that line. It has to be a durable device. And the device must identify the person who applied it. So keep that in mind. That's really important that we do that. Now, in summary, we have to keep in mind that the affected employees, now remember, the people working on the equipment, they're the authorized employees. People working around the equipment or in the area or running the equipment, they're affected. They must understand the energy control procedures, and they must stay clear of the equipment while it's under lockout tagout, because they can't help and they can't assist. So that's pretty simple. Lockout tagout is not a difficult program. It's a pretty easy program as long as we follow the procedures and do the things we're supposed to. 29 CFR 1910-147 if you want to look at the rules and regulations for lockout tagout. Now, another program that we work with a lot is called hazard communication. This is employee training. We're talking about chemicals. Now we're talking about hazardous chemicals. 29 CFR 1910-1200 is where you find the rules and regulations for hazard communication. So this is part of the employee training for hazard communication. You know, over the past few years, we've implemented the new GHS, Global Harmonized System for Hazard Communication. And this is some of the labels that you might see. They might not look exactly like this, but it'll have this type of information on it, is what I'm trying to say. A product identifier, supplier identification, precautionary statements. These are really good if you'll just take a few moments to look at them. We have pictograms that'll tell us what the hazards are. You look at these pictures and they identify the hazard for this particular hazardous chemical. Danger word, signal word, I'm sorry, it says danger. And then you have hazard statement that tells you a little bit about it. Now this hazard statement looks right here at these pictures. Now when we talk about this, highly flammable liquid, there's a fire symbol. May cause liver and kidney damage. This is a health hazard. So when you see these two emblems, once you become familiar with these emblems, you can look right at the label and say, oh my goodness, I have to make sure I have my gloves on, or maybe I have my apron on, or my face shield, something along that line, because this is a health hazard and it's a flammable. Now when we talk about the different hazards, these are the pictures that you'll see. There are 9 of them. We saw this just a moment ago, the health hazard, and this is the flammability. It tells you it's flammable. Exclamation mark basically means it's an irritant. Gas cylinder means it's under pressure. You'll see that on most spray cans today now. You'll see this emblem on that. Corrosive means it can burn you. It's skin irritant, can cause burns on skin, maybe your eyes or something like that. You definitely want to use a face shield or safety glasses when you're dealing with this particular chemical. Exploding bomb, I bet I don't have to describe that. It explodes. Flame over circle means it's an oxidizer. It won't burn on its own, but if you mix it with something that will burn, it becomes incredibly flammable. Environmental, aquatic toxicity, sometimes it'll say marine pollutant, just don't let it get in the water. And then skull and crossbones. It's pretty serious. I think we all know what that is. Normally some kind of poison. It says acute toxicity, fatal or toxic. Remember, acute means quickly. Chronic means over a long period of time. So this says acute toxicity. It means something can happen to you fairly quickly if you become heavily exposed to that particular chemical. Now on the new labels, we talked about the product identifier. It asks you what is the material. It tells you what that is. Signal word means danger or warning. And trust me, if you see that on a label, then that's your signal at that moment to look and see what's going on with that chemical. If it says danger or warning, I need more information. Hazard statement, what are the hazards? I read one off to you just a moment ago. Pictogram shows you those 9 images I just showed you. Precautionary statement, what to do for safe handling, use and storage, and the name and address and phone number of the manufacturer, importer, or distributor. It could be helpful to you somewhere down the road. Now, workplace labels must be maintained on containers, including but not limited to tanks, totes, drums, original containers, 5-gallon buckets, whatever it might be. They have to stay on there. They have to be legible if it is a hazardous chemical with one of those symbols on there. The labels must continue to be legible, contain the information that you need to know, and not be able to be defaced. If they're torn off, trust me, you can get a citation for not having it properly labeled. Make sure those labels stay in good shape. If you happen to have one that's either coming off or it's defaced or got skin up, always call. That's where that name and number of the distributor we talked about a moment ago, call and tell them to send you a new label. That will fix that right up for you. Safety data sheets. Do you know where your safety data sheets are located? They're somewhere there in your facility. Safety data sheets are created by the manufacturer so that you know about this particular hazardous chemical. GHS uses 16 sections, 1 through 16, to identify the type of hazards and the results of handling it safely on the SDS. So we'll look at some of those. The SDS sheet also identifies the chemical by name, tells the potential harm in the chemicals and how it will enter the body. It will only enter the body 1 of 3 ways. Either you will inhale it, you'll ingest it, or you'll absorb it. One of those 3 ways. It explains the signs and symptoms. If you get exposed to it, what's going to happen? What feeling are you going to have? What does it smell like? There's a lot of things you need to know. Am I going to start getting dizzy, or will I feel faint, or will my skin start to burn? Those are things you need to know when you're dealing with a hazardous chemical. And it also explains the emergency procedure. So there's a lot of good information there you're going to need to know if you're dealing with any of these hazardous chemicals. Now, again, not all chemicals are hazard, and some of you may not be dealing with any chemicals at all. This is still good information for you. Now, we talked about safety data sheets. Here's the format. We said there were 16 sections. Section 1, and keep this in mind, now this is in sections. It's kind of numerically in order so that we can find things quickly today. So, identification of the substance and the supplier, hazard identification, composition information on ingredients. Pay attention to this. Section 4 is first aid. Section 5 is firefighting. Those are 2 important things you need to know. If you get it on you and you need to know what to do, go to Section 4 on the SDS sheet. That's where the information is that tells you what to do in case you're exposed to that particular chemical. 6 is an accidental release. 7, handling and storage, how to properly handle it and storage. 8 is critically important. This is information you must know when you're dealing with a hazardous chemical. Exposure controls and personal protection. Do I need gloves? Do I need respirator? Do I need a face shield? Do I need what do I need? Section 8 will tell you exactly what you need to wear to protect yourself from this particular chemical. Now, I said there were 16. That was the first 8. Here's the last 8. Physical and chemical properties, stability and reactivity, toxicology. Some of these are information for EPA. Some of it is for federal motor carriers, for transportation, and then any other information that the chemical designer decides or manufacturer that you might need to know for this particular chemical. Now, SDSs must be available in the workplace for each hazardous chemical used. Key word there, used. OSHA requires these forms on each hazardous chemical. Your SDS station, be sure to find out where it's at. If you've never looked at it, maybe you know where it's at. Maybe it's over there by the time clock, or it's over there by the break area. Take 5 minutes one day and go and look at it. Open it up and see what's in there. When I set up an SDS book or a right-to-know station, the first thing I'm going to do is a chemical inventory. I'm going to list all the hazardous chemicals that we have in the facility. And if ammonia is the first thing on my list, then ammonia is going to be my first SDS. I'm going to key it alphabetically to my chemical inventory. Then once I finish that, I'm going to put a copy of the hazard communication written program in the back. So I have chemical inventory, my SDSs, my written program, all in one book. It's available anytime somebody wants to walk by there and take a look at it. And that's important because here it has to be readily accessible during each work shift to employees when they are in their work areas, and that satisfies that part of the standard. So hazard communication is not a difficult thing to do. It's a pretty easy thing to abide by, but it's important that you know what type chemicals you're dealing with. So today we've talked about lockout tagout from the affected standpoint. Now we've covered hazard communications, GHS, Global Harmonized Systems, gone through the chemicals and the hazards and the SDSs, and so hope you picked up something, and hope you have a really good day, and I thank you for listening.